Good morning, student. Welcome to the physics class. So today we are going to discuss about the Maxwell's right hand rule. So what we can do using the Maxwell right hand rule and what we can find using the Maxwell right hand rule. We'll discuss these things, and we'll also see how the current carrying loop act as a magnetic dipole. Okay, so if current will be flowing in a particular direction, let's say clockwise or anti-clockwise, so which means a pole will be means you can say acted during that condition. So we will be discussing these things in detail. Okay, so let's start the today's class. So I'm just going to share the screen here. Okay, so here we are going to discuss about the Maxwell. Basically, we are going to discuss about the Maxwell's right hand thumb rule. Maxwell right hand thumb rule. So let's see what is the use of this Maxwell right hand thumb rule and how this is applicable. Okay, so Maxwell right hand thumb rule is used to determine the direction of magnetic field due to straight current carrying conductor. So we can write here the Maxwell right hand thumb rule is used to determine the direction of magnetic field due to straight current carrying conductor. So what we are willing, if I am saying that it is a wire and we are willing to find out the direction of magnetic field, and this current I is flowing in it in this direction. So according to Maxwell right hand thumb rule, what we are saying means if you are holding the current carrying straight wire using your right hand, okay, then the thumb will represent the direction of current. If thumb is along the direction of electric current, then the fingers which are means just curling or gripping, that will represent the direction of magnetic field. Okay, so we can write here, if we hold a current carrying conductor by our right hand in such a way so that thumb is along the direction of current, thumb is along the direction of current. Okay, so if thumb is along the direction of current, then the grip, or you can say the fingers, will be representing the direction of magnetic field. Then Then wait for a minute, we have just some problem here. So we can say the direction of current, then the fingers or curl will represent the direction of magnetic field. Magnetic field. Let's see here. Let's try to understand here. I made here wire, but it's not. It is just behind the text. So once again, I am making wire here. So this is wire, and the current is flowing in this direction. And if you are, you can understand this way. Suppose this is wire and current is moving in upward direction. You are holding this. You are holding this current carrying conductor. Then your finger or curl will represent the direction of magnetic field. If and only if when your thumb will represent the direction of current. So if you are holding it, so your curled finger will be going inside here, inside the plane. So here the magnetic field will be inside the field plane. We can write here the magnetic field will inside the plane. While at this side the magnetic field will be outside the plane, because if you are holding and you are just curling your finger, so look here, this will be coming outward, means coming towards us. So here the magnetic field will be magnetic field will outside the plane. So this is the basically the case how we can just determine the direction of magnetic field. Okay, suppose you are willing to find out magnetic field at different places. So due to current carrying conductor. So if this is your current carrying conductor, if you are willing to find out the magnetic field here at this point, and you are willing to find out the magnetic field at this point B, and you are willing to find out the magnetic field at this point C, and here at D. So what you can do, you can just curl your finger at these points, okay, by holding the wire. So you will see the magnetic field be inside the plane, everywhere, inside the plane, everywhere. And it will be forming circle like this. And this will be your direction of your, you can say the curl. And these are basically the magnetic field. The magnetic field will be like a concentric circles, and whose center will be lying at the point where the wire is passing. Okay, so you can see that these will be the effect, and this can be drawn. This can be how this can be drawn. Suppose you are taking a wire and a wire in this way, and you are taking you are just holding the paper here, and you are taking the magnetic compass, and you are just putting magnetic compass here. It will show certain deflection, and you are just moving this magnetic compass ahead, then it will show certain direction. Once you will just place this magnetic compass at every place, so if you are just joining the line, or you can say the joining the direction shown by the magnetic compass, it will form a circle. Okay, so at different places, if you are putting and you are just changing the position at each and every time, and you are joining the line of direction of magnetic field, so it will form the concentric circle. I think it is clear to all of you. Okay, so coming to the next point, that is a magnetic field due to current through circular loop. So what will happen if we are saying that we are just passing electric current to the circular loop? What will happen? Let's see it. Let me delete it first. It's very interesting topic, students. So if we'll go through these topics, you will really love the physics. Okay. So this is a magnetic field due to current through circular loop. This is the case if you are saying that you have a circular loop like this. Okay, if you are saying this, you have a circular loop like this. Okay, or you can draw it. Okay, I can make a better diagram from this. Okay, let's see here how I can draw. Okay, so this is the case. Suppose I current is flowing in it. This current is flowing like this. If current will flow, you can see here. Here it will act like a straight wire. So magnetic field will be like this. This will be the magnetic field. Okay, if you are holding this wire like this will be the magnetic field. And this will be the concentric circles here. The concentric circles will be there. That will showing the magnetic field at different position due to this wire. So you can hold this. I mean, so you can just hold the this current carrying conductor to find out the direction of magnetic field. And let's say direction of magnetic field is in this direction. I'm just assuming it. If it is this direction, and here you are once again you are drawing the direction of magnetic field. Here it will be like this. Now the direction will be like this. These are the basically the direction of magnetic field. And what you will see it will be like this. You will see here the magnetic field will be, means if you're drawing more points, like this. So you can see here the direction of magnetic field will be like this only. This will be the direction of magnetic field. It means magnetic field is there and the magnetic field is moving like this. This is the direction of magnetic field. So it means what? If there is any circular loop, if there is any circular loop and current is flowing through it, then it will act like a magnetic dipole. Very interesting fact about the magnet. If you are breaking the magnet, suppose this is magnet, it having a north pole and south pole. इसके पास north pole है, south pole है. इसको अगर आप चाहते हैं कि हम north pole को अलग कर लें, तो you can't separate out the north or south pole. You can't have a magnetic monopole. एक सिंगल मोनोपोल आपके पास नहीं हो सकता है. और सिंगल मोनोपोल नहीं हो सकता कहने का मतलब, अगर आप इसको आप ब्रेक करेंगे, इफ इट इज नॉर्थ पोल एंड इट इज साउथ पोल, अगर आप ब्रेक कर देंगे तो यहाँ साउथ बन जाएगा और फिर ये नॉर्थ बन जाएगा. मींस मैग्नेटिक मोनोपोल डज नॉट एग्जिस्ट. ओके, सो जब भी एग्जिस्ट करता है तो मैग्नेटिक डाइपोल ही एग्जिस्ट करता है. मैग्नेटिक डाइपोल का मतलब ये हो गया, इट विल हैव अ नॉर्थ पोल as well as a south pole. Okay, so here we can say, here we can write, dear students, so the magnetic field lines due to circular coil is shown in figure. There will be the magnetic field lines that will be passing through the circular loop, and the means these will be in form of the concentric circles. Okay, the magnetic field produced by this current carrying loop will be in the form of a circle. Okay, so if we'll just means make like this. So you know about the magnetic field lines, it originates from north. Okay, it originates from north and it go north to south outside, but inside the magnet it will move from south to north. So it is, if it is moving like this, if it is moving like this, you are seeing like this. So inside the circular loop it will be like this. It will be your south pole and it will be your north pole. Okay, but outside it will be north to south. You can see. So we can write here some important point regarding this. So what we can write here, the magnetic field lines, the magnetic field lines due to circular coil circular coils means or in form of concentric circle. You can see यहाँ देखिए concentric circles बन रहे हैं. Okay, so at every point on a current carrying circular loop, at every point on current carrying circular loop, the magnetic field is in the form of concentric circle around it. Okay, so you can see, you can just note these points like this. Suppose this is a current carrying loop and you are seeing that the current is flowing in this direction. So if current is flowing like this is the direction of current, and here this is direction of current. So here the current is flowing in which direction? This is your anti-clockwise. This one is your anti-clockwise. So if current is flowing in anti-clockwise, you should remember, students, it will act like a south pole. And if current is flowing in clockwise, then it will act as a south pole. Okay, so you can remember like this. Suppose any circle is there or current carrying loop is there. If you are looking from front, अगर आप सामने से देखते हैं, अगर वो आपको नॉर्थ पोल दिखाई देता है, तो जो अंदर होगा, अगर इसको पीछे से देखा जाएगा तो ये क्या दिखाई देगा? ये आपको, अगर ये एंटी क्लॉकवाइज दिखाई दे रहा है तो पीछे से लेकिन क्लॉकवाइज दिखाई देगा. अगर सामने से क्लॉकवाइज दिखाई दे रहा है तो पीछे से क्या दिखाई देगा? एंटी क्लॉकवाइज. तो इसका मतलब ये होगा कि अगर कोई सर्कुलर लूप होता है तो इट कंटेन्स बोथ पोल, नॉर्थ पोल एंड साउथ पोल. तो आप आइडेंटिफाई कैसे करोगे? अगर सामने से देखने पे आपको लगता है कि करंट की जो डायरेक्शन है दैट इज in anti-clockwise, it means what? It will having a north pole in front, और जो बैक में हो जाएगा वो क्या हो जाएगा? आपका साउथ पोल. अगर आप देखते हैं करंट की डायरेक्शन क्लॉकवाइज में है सर्कुलर लूप में, तो इसका मतलब फ्रंट वाला दैट विल एक्ट एज अ साउथ पोल बट द बैक विल एक्ट एज अ नॉर्थ पोल. ये आपको याद रखना है बच्चे, ये बहुत ही इंपॉर्टेंट है. ओके, तो अगर हम बात कर लेते हैं कि जो मैग्नेटिक फील्ड जो प्रोड्यूस किया जाता है एट द सेंटर पे किन किन चीजों पे डिपेंड करता है, लेट्स सी इट. मैग्नेटिक फील्ड produced by circular loop depends on. देखिए डिपेंडेंसी किसके किस पे होती है? B is directly proportional to I. जितना ज्यादा करंट इसमें फ्लो करेगा बच्चे, जितना ज्यादा करंट सर्कुलर लूप में फ्लो करेगा उतना ज्यादा मैग्नेटिक फील्ड होगा. एट सेंटर की मैं बात कर रहा हूं, आई एम टॉकिंग अबाउट दिस सेंटर. मैं एक्सिस पे भी बात करूंगा. देखिए ये आई पे डिपेंड करेगा, और दूसरा इट विल बी इनवर्सली प्रोपोर्शनल टू द रेडियस ऑफ द सर्कल. इफ देयर इज अ रेडियस ऑफ द सर्कल आर, इट विल बी इनवर्सली प्रोपोर्शनल टू दिस, and it will be also dependent upon number of turns. N is your, basically you can say the number of turns. Okay, at the center, if it is your current carrying loop, and if you are willing to know the magnetic field at the center, at this point, at the center, the B will be, the formula of B is mu naught I upon 2R. Okay, this is the basically formula actually. You can say, you can write like this, mu naught I. Okay, so this will be, let me write in somewhere else. Okay, I will write this thing in a next page. But you can see here, you can see at the center the magnetic field will be different, and along the axis it will be different. Okay, so I will write the formula, but you can see the dependency. So it will be dependent on the strength of the current, or you can say the magnitude of current. It will be inversely proportional to the this radius, whatever the radius will be there. And if there is a large radius, then magnetic field will be smaller. And if there is a n number of turns of the loop, then the magnetic field, the strength of magnetic field will be increased. Okay, so if you are willing to know the formula, so let me write first. Okay, coming to the next page. So I was saying like this, suppose this is your current carrying loop like this, and you are willing to find out the magnetic field here. So this will be your mu naught I upon 2R, and R is your radius, where B is your magnetic field at center, magnetic field at center, एंड म्यू नॉट इज बेसिकली मैग्नेटिक परमेबिलिटी. आपके सिलेबस में बच्चे फॉर्मूला नहीं है, बट फॉर योर इंफॉर्मेशन आई एम राइटिंग द फॉर्मूला. ओके, मैग्नेटिक परमेबिलिटी, आई इज करंट and R is your radius of loop. Radius of loop. For n turns, you can write here, for n turns of loop, what we can write, B will be your n times of mu naught I upon 2R. So this will be the formula. Now students, look, now we can just find out the direction of magnetic field at the center. Till now we have studied that how we can find out the direction of magnetic field due to straight wire. Now if you are willing to find out the direction of magnetic field due to circular loop, so you can see here, if it is moving in this direction, which is, let's say, anti-clockwise direction, and in this case if it is moving like this direction. Okay, so what you need to do, now the things will be reversed. Now the curled finger means your finger will be representing the direction of current, and thumb will representing the direction of magnetic field. So using the right hand rule, what we are going to do, we are just going to curl our fingers in the direction of current, and the thumb, whatever will be the direction of thumb, that will be representing the direction of magnetic field. In the first case, if you are just curling the finger like this, so this is the direction of what? This is direction of current. If it is direction of current, then thumb is pointing outward. So magnetic field due to this at the center will be pointing outside. So B will be here, outside plane. Outside plane. But in this case, if you are means just curling our finger like this, and the thumb is representing inside the plane, so here the magnetic field will be inside the plane. So B will be your inside plane. Inside plane. So we will be discussing further. Okay. So for today's, this will be the enough for you. And please go through your textbook and study. And wherever you are feeling doubt, let me know. I will just clear all your doubt. Okay. So that's it for today's class. Okay.